Good afternoon and welcome everyone to today's CPD session with Richard Dunlop from Heliguy. Richard is the new head of geospatial there, and we're delighted to be able to welcome him. He is going to be talking today about taking construction to new heights, the revolutionary impact of drones on the UK and the global construction industry. It's a fascinating look at cutting-edge world technology for drones and the transformative influence on the architecture, engineering and construction, or AEC as it's frequently referred to, industry. So, Richard, I am going to hand over to you and step into the background. Do you just want to double check that your presentation can be shared, and then I can hand over to you?
There we go. Can everyone see that?
Oops. No, not yet.
Not yet. Just one sec. Right. Share screen.
That's looking good. Oh, there we are.
There we go. Is that on?
And then it is, but it's there we go. There we are.
Super.
Perfect.
Excellent.
I'm going to.
Super. So hello everyone. My name is Richard Dunlop. I am the head of geospatial at Heliguy. So today we're going to be discussing this topic, as Eleanor said. So it's taking construction to new heights, the revolutionary impact of drones to the UK and global construction companies. So we'll have a few topics to cover, and I'll discuss these now. So there we are. That's me. And as I say, my name's Richard, head of geospatial here at Heliguy. So primarily working within AEC and survey companies, but as I'll come on to, that does apply to different industries as well. My role here at Heliguy. So just before we go into the talk and some of the case studies, I'll just introduce myself in a little bit more detail. So my background has been in surveying and mapping science as a graduate from Newcastle University. I was there for 4 years. And I've also had experience sort of in land surveying as an industry as well, working at 7 partnerships. So this was on different projects around the UK, RAF Lossiemouth, down in London, on Charing Cross Railway. So I've had experience with that in the survey industry. My role now as head of geospatial sort of is using the process I've learned in my previous experience and applying it to where I am now at Heliguy, so drones, and using sort of survey data and knowledge and applying them to the use of drones. And this has worked well in the sense that we work with a number of different organisations and share that knowledge and share how drones can be used to benefit the work they do. So that could be with Balfour Beatty, Langer Hawke, sort of key players in AEC, but then the processes we have also do apply to different industries as well. So archaeology, and then even stuff like media and blue light and police and emergency services, the processes and the survey techniques do have application in those industries. But for the talk today, we're going to primarily focus on AEC. So we have 5 main topics to go through today. So the first one being the introduction. So Heliguy's role in UK construction. The second one, we'll have enterprise drone solutions. So we'll go over the main hardware, software and workflows. So what's currently being used and how it's used. After that, we'll go into drone survey applications. So again, similar to that one. So what drones are being used in the UK for construction and the software. Then 4 and 5 will actually get into the case studies themselves. So hopefully put into context what we've discussed in the previous few slides. So case studies from Balfour Beatty Vinci, Langer Hawke and Boskalis in the UK. And then another one further afield in the USA. So how drones, which are used very similar in the USA, but just sort of slightly different, and going over how it's used there as well. So the first bit is going to discuss the role of Heliguy. So Heliguy is now the DJI's one and only gold partner in the UK. So our role now is essentially to sort of sell the enterprise drones in the UK. So drones for the police, for AEC, for those sort of industries and people that want to sort of use enterprise drones. So that could be thermal, photogrammetry, LiDAR, those sort of applications. But here at Heliguy, we do appreciate that it's not a case of click and buy. It's not just the drone that you want. You may want the solution. So this is the idea of us being industry focused specialists. So we can then provide sort of consultation on the software, which is best to go with it, the training which is necessary, all of those different factors. So with that in mind, that makes us a CAA approved drone training provider. So as I say, we won't just sell you the drone and tell you to get on with it. We provide the training alongside that. So you can get your GVC license. Regulations are constantly changing. So we'll be working with the CAA to provide training to support people that want to buy the up and coming drones for like BV loss, EV loss operations. And it's an application focused approach as well. So particularly with our role in the sort of survey geospatial team, it's sort of everyone's a bit different. So it's sort of appreciating what their requirements are and then giving them sort of the best drone and software for what they want to do. And we sort of guide them and train them how to use that. And then also the complementary partner ecosystem. It's this idea that drones can be used alongside other sort of processing techniques. So you may want sort of survey, land-based terrestrial survey equipment alongside the drones. We can help provide that as well. And also other recommendations outside of DJI to either support the drone or just be used as a standalone product. Here we are. Has that worked? Yeah. So, but our sort of main partner is DJI Enterprise. So what we're going to talk about today is the main products in that and how they're used within the construction industry. So DJI, if you didn't know, is drones, and that's what we're going to talk about now. So within the field of survey, currently there's sort of three main products, and there will be new products coming out in time. So we'll be sort of learning them as they come out. But for now, these are the sort of three main ones, I would say. So you have the Mavic 3 Enterprise series in the middle. Those are sort of your sort of base solution to surveying with drones. So you have drones such as the Mavic 3 Thermal for sort of thermal operations, your Enterprise for mapping, and then your multispectral for sort of smart agriculture applications. Outside of that, you then have the M350 airframe. And with this, you can attach a range of different payloads. So on the left and the right, we have two there as examples. So you have the P1 on the left, which is a 45 megapixel camera. So for 3D models, surveying and construction and mapping, again, an excellent tool to have. And then on the right, we have the LiDAR. So the Zenmuse L1 sensor there as an example. So LiDAR, again, excellent working through vegetation where sort of photogrammetry might struggle. And then with the M350, which is the actual aircraft itself, you may have sort of custom payloads, which you may have a mount for to bolt on. So different sort of sensors can be attached to this one as well. But as drones, I would say these are sort of the major players at the moment. So once you've got that data, you need to use it. You can't just sort of have it as photos. So with this in mind, there's a few sort of softwares you can go with. Well, lots of softwares, I'd say. So the first one here is DJI Terra. So if you want to keep within the DJI ecosystem, this is a good software to have. So with this, you can generate a range of different outputs, including like a 3D point cloud for your vector data, an orthomosaic and a 2D map to sort of make measurements and volume calculations, digital elevation models, and a range of outputs. One of the benefits of Terra is it's directly sort of georeference data to OSGB36 British National Grid. So if you wanted to say put your data in the British coordinate system for making a topographic map or anything, you have capacity to do that in Terra straight from the data, like using the data directly from the drone to then get it out in that coordinate system. So that's DJI Terra. Terra is a desktop software as well, so that's unique to one PC. So I'd recommend this more so for sort of like smaller scale mapping companies. But with the LiDAR as well, it can also be used in larger construction firms as well. But then outside of this, there are a range of different softwares which are directly compatible with the data you can get from sort of DJI drones. So this could be Pix4D Mapper, which is similar to Terra. But then you also have stuff like Drone Deploy and Esri Site Scan. So these sort of softwares are excellent for the larger construction firms. The reason for this is it's cloud-based, so it doesn't depend on how powerful your computer is. And also you can invite lots of different stakeholders into that one case study. So it may be that an engineering team needs to view the data, not a surveyor. So they can directly view that data in a software such as Drone Deploy or Site Scan. And then just at the bottom there, we also have Terra Solid. So this is just an example of a software once you've actually processed data from the drone in a software such as DJI Terra or Drone Deploy or Esri Site Scan. So with Terra Solid, you can manipulate that data further. You could manipulate it further in a software such as Esri ArcGIS Pro. The point being, once you've actually got that drone data, there's like lots of different ways you can manipulate that into how you want to use it. And that's where we can sort of help out with that. So just to provide some examples of what you can get with the drone, it could be used in progress monitoring. So just standard site assessment, seeing how sites change from one day to the next. ArcGIS, so you could plug it in there to produce different types of models, so hill shade models, as an example there. Topographic mapping, the data can be used to sort of produce topographic maps, particularly in hard to reach areas where you might not be able to use terrestrial survey equipment. At the bottom left, we have 3D mesh and heritage assessment. So data from the drone could be used to assess sort of cathedrals, producing detailed 3D models. BIM and digital twins. So again, this idea that everything's moving digital, it can help support a digital twin, and the drone data can then be fed into sort of stuff like airflow and data within that BIM model. And at the bottom right, we have volumetric. So one that's quite a popular application within construction, working out cut and fill volume. So how much you may need to bring into site, or how much sort of cut and fill needs to be moved from site. And that's you can do the volume calculations directly in software such as Site Scan, Drone Deploy, Terra. Most of them support that feature. So hopefully that provided a good sort of taste of the data you can get from the drones, the software used, and the drones that are used. But now we'll get into the actual application itself. So we're going to focus on UK construction first. So the application of drones in UK construction. So the first one we're going to talk about is Biscalis Westminster, who's a good client of Heliguy. So they started introducing drones 7 years ago with the Phantom 4 series. And for what they needed at the time, it was an excellent bit of kit. But as time's moved on and technology's improved, they've upgraded their fleet to the latest sort of technology. So a bit about Biscalis first. They are primarily involved in maritime services. So on the coast and the coastline defence and coastline sort of construction. And then this is how the drones have been used. So at the moment, they have drones such as the Matrice 300. They use it with LiDAR and photogrammetry. And they use the Phantom 4 RTK, but they'll also use drones such as the Mavic 3 Enterprise. And Heliguy have worked closely with Biscalis over the past 3 years. So we've offered training and survey training, which would be through myself and other people in our team. And then we've also helped provide the kit as well. And that's how they use Heliguy as a client or as a support member. So this particular case study of Biscalis was in Portsmouth, so the South Sea Coastal Defence. So you can sort of see the defence there in the picture on the right. And sort of the reason behind it was because it was an aging coastal defence. So sort of 8,000 properties behind it and 704 businesses were at risk. So they needed to quickly renovate this sort of 4.5 kilometre area of coastline with a sea defence that was working to protect these sort of businesses. And that's where the drones came in. So they would obviously have their standard site work that they needed to do. But what the drones allowed them to do was quickly work out volumes and quickly sort of capture data, which could be sort of used alongside the data that we're using with the standard site work. So with this, they use the LiDAR data at night and they use the photogrammetry data through the day. And then this is used to sort of help assess what work needs to be done on the coastline at any one time. And it's like saved a massive amount of cost. It's not having teams of people out working out these sort of volume calculations. They can do it straight with the drones. Computer's being slow. One sec. There we are. So these are sort of data sets that they've captured with the drone. So on top right, or top left, sorry, you have the LiDAR point cloud, and at the bottom left, you have the orthomosaic. So you have your raster data sets there and your vector data sets. So with this, they can work out, as I say, like the volume calculations, but they can also plug it into like dredging software in the top right. So working out how much sediment needs to be moved within sort of along the coastline, should I say. So along the coastline, they can work out how much sediment needs to be moved based on the data they've captured from the drone. And then they also use Terra Solid for further processing as well. And that's shown at the bottom right. So what's next for Boskalis? So again, they're not going to shy away from the technological improvements. They are sort of wanting to sort of move with the way the drones develop. So they'll introduce more and more Mavic 3 Enterprises, which is quite an efficient drone for what they need to do. And they also will be looking to support future EVLOS and BVLOS operations. So this could be with solutions such as the drone in a box, which will become particularly prominent in a few years. So removing the need for a pilot and just having a drone that can quickly take off from the box, capture the data, return to its box. So then they can quickly view the data without having pilots on site all the time. So that's one case study along coastal sea defence. The next one we're going to look at is Langeroog. So this one, Langeroog work on a lot of different projects around the UK, but this one focuses on their work at Everton Stadium, soon to be the biggest club in the Championship. So apologies to any Everton fans in here. So this commenced in 2018, but it has since matured. So currently at Langeroog, they operate 6 drones through a team of 8 pilots. So they have the Matrice 300, the Mavic 3 Enterprise, and the Phantom 4 RTK. But the drone team at Langeroog is someone we work quite closely with, and I'm sure they'll be looking to get more and more drones in the future, as it's something that's really benefited their work currently. So general activities at the moment include progress monitoring and site surveys, and collecting 360-degree photos of the site. So Heliguy supported them through this in terms of rental equipment, data processing support, training, purchasing. But another big factor is the drone deploy software. So as we touched on before with the cloud-based software, drone deploy is cloud-based, and it really benefits sort of large AEC firms in the UK. So they can process and share data amongst lots of different stakeholders in their organization to sort of view how the site has progressed over time, and sort of do the volume calculations and invite lots of different people into that one project. So it's more centralized within Langeroog on the Everton Stadium. So if you weren't aware, it's on the Bramley dock and it's due to complete in the 2024-25 season. The estimated cost of the project will be £500 million. So it is quite a big modern stadium, and sort of the drone data has really sort of helped and make things more efficient. And just to put into context how popular the drone data has been, it's receiving about 2,000 views per month from different stakeholders. So yes, they have a team of 8 pilots in Langeroog, but the point being that 2,000 people outside of that drone team are viewing that data per month. So it just shows how drone data is popular amongst the whole organization. So this just shows the data that they're capturing. So in the top left, well, these are all examples from Drone Deploy. So you have the 360-degree photographs of the site. The project management in the top left, so they can put annotations and labels on the site as it develops. And then at the bottom, you have the design file. So like CAD overlays that sort of design engineering teams have produced can then be put into the project with their drone data. So it's a good way to sort of quickly and effectively see how the site has changed over time. So what's next for Langeroog? So again, Langeroog is like Pascalis, they are very much open to the development of drones. So they'll be looking to bring more drones in across the course of the year. But then they're also particularly keen again on this idea of DJI dock. So the idea that a drone could do the site assessment without the need of a pilot. And this is a particular space that will grow more in the coming years, I'm sure. So the next UK construction one we're looking at, and the final one in UK construction is Balfour Beatty. So Balfour Beatty and Vinci joint venture commenced with the start of the HS2 project. So this one is focusing on HS2. So the drone bit that Heliguy supported is on the northern team, so the span of 90 kilometers at the top of the HS2. And what they're using is drones to sort of, again, do similar work, site assessment, and see how things have progressed over time. So they have 16 drones and a team of 23 pilots, and they're recently been involved with the Mavic 3 Enterprise. So we'll have a short video to play soon. But what the Mavic 3 Enterprise has done as a successor to the Phantom 4 RTK is enable them to capture drone data almost twice as fast. It's an extremely efficient drone for mapping and surveying. So similar to Langeroog's use of drone deploy, what Balfour Beatty Vinci use is Esri site scan. So it's this idea that in such a large scale project, you can invite lots of different stakeholders into that one environment to sort of view and manipulate the project together. So hopefully this video that should, fingers crossed, play will offer a bit more of an insight into how they're using the drones.
Size and scale of the project. Using drone technology.
Richard, we're not getting any volume here at this end on the video. Is that
Coming
right?
up?
No, it's sort of coming and going a little bit.
No volume. Okay.
I mean, it looks great, but the volume's just...
So let me have a look quickly. So now we fix that.
Do you want to just try again?
I'll try again. If not, if people want the video, they can just ask me at the end. I can forward it across. Is that working?
No, unfortunately not.
No worries.
Do you want to talk over it and explain a little bit about what's happening?
Yeah, I'll do that. If people want the actual video, the volume is worth having. So if they want to get in touch with me at the end, I'll be able to forward this video across. So as we just said, it's 90 kilometers length on the rail, and basically they're using the drone data sort of do like volume calculations as we've touched on before. So it's the Mavic 3 Enterprise that they're using. So traditionally it was used with sort of terrestrial based techniques, so land surveying techniques. So the data they were capturing may have taken 3 weeks to capture, but with the drones, it then enables them to do it in like 1 to 2 days. So cost savings in the sense that they can just take the drone up and fly rather than have teams of land surveyors going out for 3 weeks at a time to capture the data. So that's one of the benefits of using a drone such as the Mavic 3 Enterprise for it. So what they were saying there was just there's now 10 UAVs on site with 23 pilots using the drones. So again, it's something that they've really benefited from and sort of adopted to sort of improve and increase efficiency on site. So as you can see there in the box, you have the Phantom 4 RTK, which was essentially the drone from 3 years ago. Now the Mavic 3 Enterprise has directly replaced that model. So one of the key factors or the key differences between the two drones is its shooting interval rate, so the rate the camera can take photos of the site. So on the Phantom, it would be every 2.5 seconds, whereas on the Mavic 3 Enterprise, it's every 0.7 seconds. So just that shift in drones has enabled them, again, to improve efficiency by twice as much. And then using the data, they put it in every site scan, which you can see from this images here on screen now. So I have no idea how that sounded without the volume. Hopefully my commentary was up to scratch. I would definitely recommend watching the video. So if anyone wants it, I can share that after and share that across. So now if I can just get off this video. There we are. Right. So now that my amazing commentary is finished, we'll carry on with the rest of the presentation. So the final case study is going to be an international case study, so one from the USA. So again, it's the same idea as how it's used in UK construction. So improving efficiency is sort of the main benefit, and then improving that efficiency, but with accurate data as well. So it's used very like similar across in America, just with a slightly different software. So the global case study focuses on the company Fior and Sons, and similar to the video was showing, they use a Mavic 3 Enterprise and Propeller Aero software to process their 85-acre site. So what the Mavic 3 Enterprise does is it allows them to fly across the site and capture data in less than an hour with just that one single flight. And then the Propeller Aero software is similar to like the site scans and the drone deploys, a cloud-based platform where you can have multiple different stakeholders in that one environment doing volume calculations and manipulating and viewing the data. So that's how it's used in Texas. And then in that sort of software, they'll do the same process of cut and fill volumes, progress monitoring, site assessment. So that's how it's really benefiting AEC at the moment. So the picture on the right just shows what is the 2D orthomosaic. So the 2D map essentially of the map of the site, sorry. And then from that they'll do the cut and fill volumes. And what they've adopted is a PPK workflow. So a post-processing kinematic workflow to ensure data is collected to an appropriate level of accuracy. So when they're flying the drone, they'll have control points on the ground that they use to help further improve the accuracy of the data local to their coordinate system. So not only have they got that 2D map, but they are sort of getting a verification that it's accurate with the use of this workflow using ground control points in conjunction with the data that they've captured with the drone. So that's the end of my talk. I do apologize for the video. I'm not sure why the volume wasn't playing there, but as I say, if anyone wants it, just let me know. I've got my email in the bottom left, and if there's any questions, I'm happy to help now.
That's great. Thank you very much indeed, Richard, and well done dealing with that on the fly. Sometimes, and I'm sure you could probably hear it talking in your own
could hear it,
background,
yeah.
but we couldn't hear. Unfortunately, if you want to send the video over to me, I can include it with
Yeah, I'll
email
do that.
or a link possibly
Yeah.
this afternoon when I send out this the watch again links, etc., to all those who have registered. And there are unfortunately always a few who can't actually then attend in person. That was fascinating. Thank you very much, and a really good insight into some of the improvements that have actually happened within the industry along the way. So from the shutter speed side of things through to the efficiencies that are available. It really does it's absolutely fascinating and eye-opening when you think that project work that previously took 3 weeks is taking 1 to 2 days now on site. So that's a huge improvement, and heaven knows what the cost and the length of the project for HS2 would be without actually drones being involved.
Yeah.
So well done being involved there. So we're sorry.
Should I stop sharing there? Sorry.
Yeah. Do you want to stop sharing? And we can. There we go. And if we have some questions, please do feel free. That we find the discussions always improve with people adding questions in. So we have a couple which we'll start off with. Thank you from Annalise. Progress in technology is really fascinating. It seems that you can do most missions with the Mavic 3K RTK. What proportion of missions and construction do you think you can cover with that solution?
Sorry, my internet just glitched out there. Is it in the one in the Q&A now? Yes.
Yeah, that's right. So it's the top one you and I are looking at. So
the top one there, yeah. To be honest, I would say the mapping mission can cover the majority of all your missions. So just like the standard mapping mission with it facing the deer, so top-down camera. For volume, cut and fill, that's absolutely spot on. If you would then look into further that for 3D models, you could fly oblique. So with the camera at multiple different angles, that would also work well if you wanted, say, more data on the sides of buildings. But then, as I say, if you wanted to fly manually, you could also use that data that you've flown the mapping mission with and use that sort of with manual flying as well. So you'd still get an even more detailed 3D model from that. But I would say most of the mapping missions you need to do will be pre-installed onto the controller.
Mm-hmm. That's handy. Are 3D photogrammetry models detailed enough to replace individual still images used for roof surveying? Can you still assess the condition of the roof to the same extent? I'd like our company to start using them, but we are not sure if the quality of the imagery is equal to individual still images.
Depends how you want to use it, I would say. For like standard like visual like inspection purposes, it depends on the drone, but with the Mavic 3 Enterprise, you still got a 20 megapixel camera there, so it's rivaling the likes of a Mavic 3 Pro or a Mavic Air 2S with its actual still imagery. So I'd still say it's capable of doing that. One of the things I do think photogrammetry is good for is if you want to take specific measurements using any one of the softwares we've went through there. So you could do your 2D mapping mission with a drone such as the Mavic 3 Enterprise, and then get centimeter level accurate measurements in the software. So the reason you can do that is because on top of the Mavic 3 Enterprise, you have the RTK module. So basically that's giving you access to more accurate satellites and like corrections that can then be fed in directly into the drone data. So then when you want to actually start taking measurements of the roof, you have the sort of the capacity to do that straight away because of the RTK connection. So if that's sort of something you'd want to do with the roof surveying, I'd say that's definitely something to consider with a drone such as the Mavic 3 Enterprise.
Thank you. That leads nicely on actually into the next question, which is, first of all, thanking you for the presentation. But what's the accuracy of the data? I mean, obviously that depends on what you're using more than anything else. But do you want to give us an overview of some of the different types of software and the accuracy available?
Accuracy is a funny one because it comes in like different forms. So you have relative and absolute accuracy. So if we were just talking about what we said there, where it was you're using it to take measurements of the roof, it'd be at the centimeter level. So the ability to take centimeter level accurate measurements of a roof or something in the built environment, that's spot on. But then when you come on to absolute accuracy, so the accuracy of the drone in a coordinate system, it varies really. So in terms of straight from the drone using the RTK, as I mentioned before, you're probably going to be looking about 2 to 3 centimeters in planimetric and horizontal accuracy, and about 5 centimeters in vertical accuracy. But then if you're using sort of land-based survey data as well, so ground control points alongside the drone data, providing they're well distributed, you could again further improve the accuracy. So then you could be looking at 1 to 2 centimeters in planimetric accuracy and probably about 2 to 3 centimeters in height. It really does vary from site to site, but I'd say that's a rough sort of idea on what accuracy you can achieve with ground control points and like drone survey data.
Thank you. That's a really good insight. Thank you. So that's answered the sort of the 4 initial questions that we've had there. Are there any others that people want to suggest at all? We're here. Richard is here. He has a wealth of knowledge at his fingertips. Well, actually, probably more in his brain more than anything else. But let's take advantage of it while we have him here. Obviously, you are more than welcome to go back to him again after this presentation, and his email, which obviously is now not on the screen, is richard.dunlop@heliguy.com.
Yeah, if anyone has any questions, please feel free to send them via email.
Sure. And again, I'll include Richard's contact details in the email that then goes out this afternoon. In the meantime, I'm also going to add in a little plug for further CPDs that we have going on this autumn as part of the ARPAS CPD program. Next week, we have a talk with from the UAvionics on delivering UAS BVLOS flight in non-segregated airspace using aviation grade command and control. BVLOS is a key topic at the moment. It will obviously be very important in due course in the construction industry as sites become larger and larger. And feeds into the fact that ARPAS has also recently set up a BVLOS technical special interest group. We held our first event last week looking at risk quantification in a workshop environment, which was a great achievement and fascinating for those who attended. Some very full and frank exchanges happening, but all really in a constructive background and setting. And sort of further enhancing what we also do, we have a webinar in October on data security for infrastructure projects. This has been run by the UK's National Protective Security Authority. This is available for members only, and also for members of RICS, UK RICS. In due course, further in October, we have Achieving Safer Skies, Enhancing Safety and Visibility in Drone Operations with Altitude Angel and Copters. And then after, I call half term, later in November, we have got discussions on using drone swarms in inspection of infrastructure strategies, and further topics will be added as we go. We tend to stick to a couple of CPDs a month because we don't want to overwhelm those who are taking part. And you are all most welcome to attend. To those that are relevant and interesting to you, we appreciate that drones operate in a number of industries, and not all of our webinars will be of interest to absolutely everyone. In the meantime, it looks like we haven't had any more questions through. Please do feel free. This is why we're here, is here to discuss and take advantage of Richard's expertise. However, I am more than happy to, oh, here we go. Otherwise, to let people go early and to give you back some time. We have another further question. What are the procedures for arranging a drone survey? Permissions, weather?
Again, it varies really. For like the sort of drones we discussed, you would first need the license. So like a GVC or an A2 CFC is a bare minimum to then do the drone survey. My personal recommendation would be the GVC, as that's more accredited by the Civil Aviation Authority. Now is sort of good airmanship to then do what's called a NOTAM. So you send a notification to airmen, it stands for. So that would be discussed on our sort of GVC training portal, but essentially firing out a notification that you're performing a drone operation that day. Once you've done that, it's just having, if you're on a site, the approval of the site manager to then fly the drone there, to then go and conduct a drone survey. Now, it does ultimately depend on weather as well. So if the weather is bad on the day or looking like it's going to be bad, it would be best to postpone it, because you do need sort of overcast conditions as a bare minimum. And then, yeah, just go from there. But in terms of actually arranging the procedure, just site approval, NOTAM, and having a license.
That's great. That's really helpful. Thank you. How does Heliguy monitor and log their UAV battery health? Do you have a life cycle program?
For myself, not really. It's just we've got some guides on our website that we can forward across, or I can get Eleanor to forward across. We have some blog posts on battery health. The batteries do have 12-month warranty, so it is something that they will ultimately deteriorate over time, especially with more and more frequent use. So it's just a case of when you are flying them, not making sure they go down fully, just stopping them at like the 20% low battery warning, and then bringing the drone into land, and then charging them up for the next flight. But we have a detailed guide that I'd send across. I'd probably explain how to properly charge the batteries better than I have just done there.
There are also other 4 different types of software as well that are available that will help you monitor and maintain a record of how you maintain your UAVs as well. There are Esri, who we've talked about earlier in today, have a project built into, or software is built into their software that you can do this. Another version as well is Drone Desk, that has an excellent form of monitoring this side of things as well. So we have CPD's webinars from both those organizations on the website if you want to watch again and learn a bit more about that too. Okay. I think that I'm going to give everyone one last minute. Do come up with any final questions. I think we've had some really useful ones in there, and that's been a really good overview of different types of drones, what their capabilities are, and how they are being used. Thank you very much indeed, Richard. Thank you for your time. And we much appreciate it. As I mentioned, this has been recorded. We will post it up onto our website and onto YouTube. Please do feel free to share it with friends, colleagues who will be interested. And in due course, I will send this further along. We've just had an anonymous attendee saying, is there a chance to have a trial for our construction team? Anonymous, would you like to either email Richard direct, richard.dunlop@heliguy.com, or if you prefer to go via me, please email me at membership@arpas.uk. Thanks very much. So thank you very much indeed, Richard. It's been a highly informative, really useful session. I will give everyone a sort of 15 minutes back of their lunch break. Thank you, and take care, everyone.
Thanks, everyone.
Bye-bye.
Bye.